Have you ever wondered how electricity flows through your devices or what happens when you adjust the resistance in a circuit? With PASCO's wireless current sensors, you can explore electrical current that flows through circuits. PASCO has two wireless current sensors. The standard wireless current sensor that comes with red and black banana to alligator clips for easy connections, and the wireless current sensor module that conveniently snaps into modular circuits. Both current sensors have a very low resistance of 0.1 ohms for accurate measurements. For this reason, we do not recommend connecting it directly across a battery or other voltage source without a resistive load. However, the sensors have built-in overload protection to prevent harm to the sensor. They feature two measurement ranges, plus or minus 1 amp and plus or minus 0.1 amps. The range is selectable inside the software and defaults to plus or minus 1 amp. Now let's set up a simple Ohm's Law lab using modular circuits and the wireless current sensor module. This lab can also be performed with wireless current sensor and traditional circuit materials. The wireless current sensor and wireless current sensor module can be connected to PASCO Capstone, SparkView, and the wireless current sensor can also be connected in ChemView. I've already connected the module to SparkView via Bluetooth and set up manual sampling. I've created our table with the resistors we'll be using: a 33 ohms, a 100 ohms, a 220 ohms, and a 330 ohms. I'm connecting the sensor in series with the resistor to find the current going through the circuit. Once I start collecting data, I can flip the switch to record the current with the 33 ohm resistor. Let's swap out for the 100 ohm resistor and repeat the process. We'll continue with our spring clip module and use standard resistors. Now that we've collected all the data, I can create a graph of current versus resistance. We can see the graph appears to form an inverse relationship. As the resistance increases, the current through the circuit decreases. Let's fit an inverse curve to the graph. For A value, we get roughly 1.4 volts, which makes sense because we're using a 1.5 volt battery. Students can easily see the relationship between current and resistance with the help of the wireless current sensors. For more information on the wireless current sensors, visit the PASCO website, where you'll find detailed specifications, related products like the wireless voltage sensor, and experiment ideas. Thanks for watching, and happy experimenting.